In the past, speech recognition mostly worked by matching recorded words to audio stored in a database. But now, thanks to faster onboard processors and the almost limitless computational power of the internet, it can go a lot further.
Find the nearest restaurant.
Apple's Siri, Android's personal assistant, plus the Bing and Google web searches can all take voice requests. Now, each of them actually just record your voice and then upload the audio to the web.
What should we do tonight?
It's there that it's broken down into individual sounds or phonemes and converted to text, where it can be treated just like any other search query. And it's getting better, although it's still not perfect. I have to say, I am quietly impressed by the quality of the speech-to-text function on high-end smartphones. But the key word there is quiet. In a lovely soundproof radio studio like this, the phone has hardly any problems picking out those phonemes, those individual parts of the words. However, pop outside into what I like to call the real world, and the thing will have huge problems working out which bits are me and which bits are everyone else. Background noise is the #1 enemy of speech recognition. And here, the mobile phone has a much harder job than, say, Xbox Kinect, which lives in one location and can scan its surroundings during setup, work out the acoustics, and then listen more effectively.
Search.
Some phones do use a second rear-facing microphone to analyse the background noise and remove it. But why use 2 when you can use 32?
Hi, it's only me. I was just ringing to tell you that I'm, as usual...
Patrick Naylor from Imperial College in London is one scientist who thinks that more is more.
Hi, this is Patrick. I was just ringing to let you know that I've arrived.
With 2 mics, the software only correctly identifies a few words, the white ones, in this text.
Hi, this is Patrick. I was just ringing to let you know that...
But with 32 mics, all recording sound from different angles, the results improve dramatically. Of course, this will only be practical when the equipment can be shrunk just a little. But if a computer is to become more than just a dictation machine, a useful personal assistant, it not only needs to capture what I say, but also understand what I meant. Excuse me, I'm looking for a lift. Sorry, I didn't bring my car today. Some words, for example, have several meanings. Excuse me, I'm looking for a lift? Sure, you're a beautiful person with a wonderful personality. It's important to understand the context of what it's been asked in order to determine which answer is correct. I wonder if this is what they meant. Modern speech recognition apps can access a vast database of language models that change and move with the current trends. They learn from past mistakes and your personal use of language, and they can even guess the next word before you say it. And this is just the first step to learning more about you and what you're likely to ask. My location, shopping habits, favourite TV programmes, music choices and my emails and social networks can all give insights into who I am, what I want and what I've said, and help a machine to arrive at more meaningful answers. So if, for example, I bought a plane ticket to Rio, the next time I say Rio, the software may guess that I'm talking about the city and not the movie. But if successful speech recognition relies so much on your personal profile, you don't really want to create a new one on every gadget you own. And that's exactly what a company called Nuance is doing, creating a profile of you that lives in the cloud and which can be accessed anywhere by anything. For example, if I want to check up on my favourite sporting events, how are the Celtics doing?
The Celtics are losing. It's 46-42, Lakers, with 11:58 left in the third.
Now, my profile has told this device that I prefer basketball to football, so it's updating me on the Celtics basketball team and not the Celtic football team. In reality, I wouldn't be able to tell the difference. Anyway, once you've finished reading about the results of the match, play the Rolling Stones.
I know it's only rock and roll, but I like it.
Now, everything that I've just done outside should have been added to my global profile, which means I can just pick up where I left off on this laptop, for example. So, put on the playlist I was listening to.
You got it.
And up come the Rolling Stones again. Watch The Fifth Element. Now here's the really cool thing. If I just pause this movie, I can show you that my profile isn't just accessible on mobile phones and laptops, but on other internet-enabled devices too. For example, that internet TV over there. So I'll use this iPhone as a remote control for the TV and say, play the movie I was watching. And pretty quickly, The Fifth Element picks up from the same point I left off on this laptop. Do you remember earlier I was supposedly interested in some sport? Well, throw on the game. It knows which game I was talking about because I asked about it earlier, and that's the New York Redlegs against the Boston Tall People, and they're winning 15-love. Now, a system that knows me better than I know myself is great, as long as it doesn't start sharing that information with others.
If you can build a profile of the person's voice and the way they use language, you'll definitely get a much better accuracy from speech recognition. It becomes personalised to you. However, there's a big but here, and that is that in many cases you really can't do that because you're building systems which are universally accessible without any knowledge of the user, or there are privacy issues associated with grazing on people's personal data to build models which may be unacceptable in some applications.
By giving them permission, you get the benefits of these, the profile and the relevant listings coming back to you. If you don't, then you'll just get a blank sort of standard response to it. On our server side, it's going to be an anonymous ID pertaining to that particular individual, and we're going to collect information and allocate it against that anonymous ID. So if anybody was able to get that information, they wouldn't know who it belonged to, and therefore wouldn't be able to make reuse of that.
And if more than one person will be using a device, the system will need to know who's speaking and then switch profiles accordingly. This visualization, also called Watson, although this time built by AT&T, uses cameras and facial recognition to identify the user who's currently talking.
Hello, Ivy.
It's one of the ultimate goals of computing. Machines that interact with us on our terms. And although Ivy here is still just a mock-up, we are approaching a time when our computers may become simple yet viable personal assistants.
Can you set a reminder in 30 minutes to take this out of the oven?
Just make sure you specify which type of jam you'd like for breakfast. Strawberry or traffic?
I would recommend leaving 15 to 20 minutes early.